Test, test. Okay, let's see. Test, test. Not hear myself. Oh, it's because the volume's really low. Test, test. There we go. So I hope that you guys can hear me just as well. Test, test. Test, test. Test, test. Test 1 2 test. Test 1 2 test. Test 1 2 test. Checking. Hey, hey. Hey, hey. That's much better. Okay. Test. Okay, now I need some music. Even though on YouTube I keep getting copyright strike. Yeah, the damn bot. Oops. And this is just instrumental music. So I have this instrumental music and I'm getting copyright strike all the time. Fucking stupid. All right, test, test. And it doesn't look like this is accurate. I wrote something else on my title. I don't know why I changed it. All right. So it looks like, yep, that's YouTube for you. Yeah. I'm just so sick of it. This is just simple instrumental music just to fill the void, fill the awkward, the awkward silence, and they have to fucking copy strike it. I have like 2 subscribers on YouTube. Okay, I'm not a threat to anybody. Stupid. Anyway. We gotta add the course Boolean expressions. Let's add Boolean expressions. There it is. Okay. And I think the other thing is also on Twitch, I can't watch videos. So my video lessons, I have to keep them off. All these fucking rules. All right. Here we go. Before we can advance and talk about how software makes decisions, we need to understand a very important concept within programming, namely booleans. A boolean is a variable that holds a binary value. What does it mean? Simply, it means yes or no value. In the book, go to the first chapter about values, types, and operators, and scroll to Boolean values. Read that section of the chapter and try to understand what it tells you. When you're finished reading, go to this web page and read it. Okay. So, gotta go to the book. Is it this one? Wait, which book? Values, types, and operators. Well, let's see if we can find something that says that. Values, types, and operators. No. Does it have like its own search engine internally or something? Values, numbers, strings, Boolean values. Could that be it? I don't like when the instructions are not exact. Like, yeah, that's it, you know. You're supposed to have some context. Oh, values, types, and operators. There it is. Alright, let's go to 1. Alright, values, types, and operators. Inside the computer's world, there's only data. You can read data, modify data, and create new data. But that which isn't data cannot be mentioned. All this data is stored as long sequences of bits and is thus fundamentally alike. Bits are any kind of two-value things, usually described as zeros and ones. Inside a computer, they take forms such as high or low electrical charge, a strong or weak signal, or a shiny or dull spot on the surface of a CD. Any piece of discrete information can be reduced to a sequence of zeros and ones and thus representative bits. So if I have two rocks, one blue rock and one red rock, then I could do like a bit. For example, we can express the number 13 in bits. It works the same way as a decimal number. By the way, I remember reading this, but I've been so behind. I had this sort of like mind fog that, you know, I just haven't been able to, or, you know, found the motivation to do this course. And if you do that, you forget things. You lose momentum. So I don't mind going about it again. For example, we can express a number 13 in bits. It works the same way as a decimal number, but instead of 10 different digits, you only have 2. And the weight of each increases by a factor of 2 from right to left. Here are the bits that make up the number 13, with the weights of the digits shown below them. Okay. So that's a binary number 00001101. Its non-zero digits stand for 8, 4, and 1, and add up to 13. Oh, okay. Because these ones are basically turning on, that's what I think, these numbers. So whatever you're going to turn on is going to get added up, I guess. One, two, three, four. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8-bit. So maybe that has to do with, you know, the early. That's what they meant with the Nintendo 8-bit system and 8-bit graphics and all that stuff. Somehow. Imagine a sea of bits, an ocean of them. A typical modern computer has more than 30 billion bits in its volatile data storage, working memory. Non-volatile storage, the hard disk or equivalent, tends to have yet a few orders of magnitude more. To be able to work with such quantities of bits without getting lost, we must separate them into chunks that represent pieces of information. In a JavaScript environment, those chunks are called values. Though all values are made of bits, they play different roles. The values play different roles? Or the values play different roles from the bits? I don't know. Every value has a type that determines its role. Some values are numbers, some values are pieces of text, some values are functions, and so on. To create a value, you must merely invoke its name. This is convenient. You don't have to gather building material for your values or pay for them. You just call for one, and whoosh, you have it. They are not really created from thin air, of course. Every value has to be stored somewhere, and if you want to use like a gigantic amount of them at the same time, you might run out of memory. Fortunately, this is a problem only if you need them all simultaneously. As soon as you no longer use a value, it will dissipate, leaving behind its bits to be recycled as building materials for the next generation of values. So that part I don't understand, but okay. I don't understand because it says that the bit is left behind, and I thought the bit was kind of like a concept. So I don't know. This chapter introduces the atomic elements of JavaScript programs, that is, the simple value types and the operators that can act on such values. You know what? I should put the chat on the side because I remember last time I had a lot of help. I had like some people help me out, help me understand. Values of the number type are, unsurprisingly, oops. Excuse me. Hello? Hello, hello? Sorry. It's a friend of mine. I guess that's what happens when you stream. Set up a video and chop it off. Chop it up. Alright, fine. I'm not gonna be chasing people. Okay, call you twice. Fucking pick up the phone, that's fine. Okay? Fucking chasing people, shit. Alright. Values of the number type are, unsurprisingly, numeric values. In a JavaScript program, they are written as follows. 13. Use that in a program and it will cause the bit pattern for the number 13 to come into existence inside the computer's memory. Is this thing too loud? There. Maybe that's a little bit better, but now I hear that whoosh. Whoosh, whoosh. Alright. Okay, so in JavaScript, I only have to type 13, 1101. I guess that's what it was. Alright. JavaScript uses a fixed number of bits, 64 of them, to store a single number value. There are only so many patterns you can make with 64 bits, which means that the number of different numbers that can be represented is limited. With n decimal digits, you can represent 10n numbers. I don't know what n means. Similarly, given 64 binary digits, you can represent 2 to the 64th power. Little rusty on the math. Different numbers, which is about 18 quintillion and 18 with 18 zeros after it. That's a lot. Computer memory used to be much smaller, and people come here. You can go Godzilla on your ass. Did I get it? Let's see. Oh. What now? There. It was easy to accidentally overflow such small numbers, to end up with a number that did not fit into the given number of bits. Today, even computers that fit in your pocket have plenty of memory, so you are free to use 64-bit chunks, and you need to worry about overflow only when dealing with truly astronomical numbers. Not all whole numbers less than 18 quadrillion fit in a JavaScript number, though. Those bits also store negative numbers, so one bit indicates the sign of the number. Okay. The bigger issue is that non-whole numbers must also be represented. Alright, such as the decimals. To do this, some of the bits are used to store the position of the decimal point. The actual maximum whole number that can be stored is more in the range of 9 quadrillion, 15 zeros, which is still pleasantly huge. Fractional numbers are written by using a dot. For every big or very small numbers, you may also use scientific notation by adding the e for exponent, followed by the exponent of the number. Okay, when I did this chapter, I remember looking up exponent and learning what exponent was, but now I forgot what exponent is because if you don't practice it, you lose it. A person who believes in and promotes the truth or benefits of an idea or theory. Exponent. Okay. A quantity representing the power to which is given to a number expression is to be raised, usually expressed as a raised symbol. Oh, okay. All right. Is that similar to an advocate? Exponent, like an advocate of an idea? Or maybe ideas don't have advocates, but they only have exponents. All right. Followed by the exponent of the number. Okay. So normally this would be what, 2.998 to the 8th power or something? No. That is 2.998 times 8, or 10 to the 8th power. So basically they're using the bits in order to make the computer do math problems. So the position of the decimals and this exponent thing here. Calculations with whole numbers, also called integers, smaller than the aforementioned 9 quadrillion, are guaranteed to always be precise. Unfortunately, calculations with fractional numbers are generally not. Just as pi cannot be precisely expressed by a finite number of decimal digits. Many numbers lose some precision when only 64 bits are available to store them. This is a shame, but it causes practical problems only in specific situations. The important thing is to be aware of it and treat fractional digital numbers as approximations, not as precise values. Well, that's good to know. Although one way to get around the decimal problem with JavaScript is to use bigger numbers. So instead of going from 1 through 10, for example, you can go from 100 to 1,000. And then if you need to chop it up, instead of saying 0.5, you can say 50. Just a thought. Since you have, like 5 quadrillion, quintillion. So anyway, arithmetic. The main thing to do with numbers is arithmetic. Arithmetic operations such as addition or multiplication take two number values and produce a new number for them. Here's what they look like in JavaScript. 100 plus 4 times 11. The plus and the asterisk symbols are called operators. The first stands for addition and the second starts for multiplication. Putting an operator between two values will apply it to those values and produce a new line. Yes, I learned that a long time ago. But does the example mean add 4 and 100 and multiply the result by 11? Or is the multiplication done before the adding? No, the adding is done first. As you might have guessed, the multiplication happens first. Really? I didn't guess that. Why would I guess that? Because I'm bad at math, that's why. But as in mathematics, you can change this by wrapping the addition in parentheses. Why would the multiplication go first? Why would that operator be before the other operator? Is it because it goes from right or from right to left? Is it because multiplication is somehow greater than addition? For subtractions, there is the minus operator, and division can be done with the backslash operator. Or is it forward slash? I don't know. When operators appear together without parentheses, the order in which they are applied is determined by the precedence of operators. This music volume is not consistent. Okay. When operators appear together with a parenthesis, the order in which they are applied is determined by the precedence of the operators. The example shows that the multiplication comes before addition. The forward slash operator has the same precedence as the asterisk. Likewise, for plus and minus. When multiple operators with the same precedence appear right next to each other, as in 1 minus 2 plus 1, they are applied left to right. Multiple operators with the same precedence. That means that I have to memorize a precedence. Why am I learning about all this math? I just want to program games. Just want to make my own games. These rules of precedence are not something you should worry about. When in doubt, just add parentheses, or look it up on Google. There is one arithmetic operator, which you might not intimately recognize. That percentage symbol is used to represent the remainder operator. X remainder y is a remainder of dividing x by y. For example, the 314 remainder by 100 produces 14. Oh, okay, because you can fit 100 3 times inside 314. And 144 remainder 12 gives 0, because you can eventually get to 144 with 12. The remainder operator's precedence is the same as that of multiplication and division. You'll also often see this operator referred to as modulo. Sounds like a Spider-Man villain. There. I think what's happening is that the different songs have different values. Well, math is important for many programmers. I hate math as well. Yeah. What's up, all cops? You need to love math. Oh my god, really? Look, I'll be honest with you guys, okay? I just want to learn enough programming so I can get away with, like, getting into the code and, like, changing some stuff around, okay? Maybe modifying somebody else's code, you know, stuff like that. Scavenge code, all that stuff. Who knows, you know, maybe I would like to write my own code. I'm working on a reactive web development right now, and it's just trying to get down this stuff still. Yeah. I just don't understand what the math has to do with like making stuff happen. You know. Is your first language? Yes, this is my first programming language. The next basic idea type is the string. Strings are used to represent text. They are written by enclosing their content in quotas. Right. You can use single quotes, double quotes, or backticks to mark strings, as long as the quotes at the start and the end of the string match. Sure. Makes sense. Almost anything can be put between quotes. In JavaScript, we'll make a string value out of it, but a few characters are more difficult. You can imagine how putting quotes between quotes might be hard. New lines. The characters you get when you press enter can be included without escaping only when the string is quoted with backticks. Characters you get when you press enter. I've never gotten a character when I press enter. To make it possible to include such characters in a string, the following notation is used. Whenever a backlash, that's a backlash, is found inside quoted text, it indicates that the character after it has a special meaning. This is called escaping the character. A quote that is preceded by a backslash will not end the string but be part of it. When an end character occurs after a backslash, it is interpreted as a new line. Similarly, a T after a backslash means a tab character. Take the following string. This is the first line and this is the second. Okay, why is that important? There are, of course, situations where you want a backslash in a string to be just a backslash, not a special code. If two backslashes follow each other, they will collapse together and only one will be left in the resulting string value. This is how the string, a new line character, is written like that. Can be expressed. A new line character is written like backslash, quote, two backslashes, so they can collapse each other, and then another backslash. Wow, that's really convoluted. Strings too have to be modeled as a series of bits to be able to exist inside the computer. The way JavaScript does this is based on the Unicode standard. This standard assigns a number to virtually every character you would ever need, including characters from Greek, Arabic, Japanese, Armenian, and so on. If we have a number for every character, a string can be described by a sequence of numbers, just like they did before with 13 and the bits. And that's what JavaScript does. But there's a complication. JavaScript's representation using 16 bits per string element. Okay, you can describe up to 2 to the 16th power different characters, but Unicode defines more characters than that, about twice as many at this point. Some characters, such as many emoji, take up 2 character positions in JavaScript strings. We'll be back to this in strings. We'll be back to this in chapter 5. That was confusing. Strings cannot be divided, multiplied, or subtracted, but the operator, the plus operator, can be used on them. It does not add, but it concatenates. It glues 2 strings together. The following line will produce a string concatenate. I remember reading about that too. All right. String values have a number of associated functions, methods. They can be used to perform other operators on them. I'll say more about these in chapter 4. Strings written with single or double quotes behave very much the same. The only difference is in which type of quote you need to escape inside of them. Backtick quoted strings, usually called template literals, can do a few more tricks. Apart from being able to span lines, They can also embed other values. Oh, this is what they mean by backtick. But isn't that just like a single quote? Oh no. Let me see. Oh, okay. So the backtick is under the curly. And it's, okay, it's like an italic version of the single quote. All right, when you write something inside money curly braces in a template literal, its result will be computed, converted to a string, and included at that position. The example produces half of 100 is 50. Right. What JavaScript, not Java, not C or Ruby or random framework? The reason is that the course that I'm taking, let me show you guys. Oh, I guess I cannot show you, or maybe I can. So the course that I bought includes JavaScript. It's just basics of JavaScript, and also basics of C, or I think C plus or something, and to teach you how to create smart contracts. And it goes from newbie, like totally green, totally not knowing what, how to program, to being able to create obviously a very simple smart contract on Ethereum, NEM, and EOS. So the course includes JavaScript. Ivan said that JavaScript is very popular, and so he wanted to include it as part of that. Also, the Ethereum, he says that the Ethereum language is very similar to JavaScript. And my last reason, to this lengthy answer is I'm making a game in RPG Maker, and in order to script in that, you need to know JavaScript. So those are the reasons. Where was I? Okay. Unary operators. Urinary operators. Not all operators are symbols. Some are written as words. One example is the type of operator, which produces a string value, naming the type of the value you give it. Console.log, type of 4.5. Okay. We will use console.log in example code to indicate that we want to see the result of evaluating something. More about that in the next chapter. The other operators shown all operated in two values, but type of takes only one. Operators that use two values are called binary operators, while those that take only one are called unary operators. Sorry, my mind is in the toilet. The minus operator can be used both as binary operator and unary operator. Okay. Okay. See, but to me, that's like a really complicated way of doing 10 minus 2. And I don't know why that is necessary, or why that needs to be that way. See, I have a feeling that all this is groundwork, and it's going to be really boring, and it's not going to get to the good stuff, so I can, start like doing stuff and knowing how all these things are relevant until later on. So I have to grind all this boring stuff, boring but necessary stuff. Yes. It is often useful to have a value that distinguishes between only two possibilities, like yes and no, or on and off, right? For this purpose, JavaScript has a Boolean type, which only has two values, true and false, which are written in those words. Comparison. There's only one way to produce Boolean values. Console.log is 3 greater than 2, true. Console.log is 3 lesser than 2, false. The greater and lesser signs are traditional symbols. For is greater than and is lesser than. Respectively, they are binary operators. Applying them results in a Boolean value that indicates whenever they hold true in this case. Strings can be compared in the same way. Console.log aardvark is lesser than Zoroaster. Who's aardvark? I think I searched for this last time. Medium-sized barring nocturnal mammal. Yeah. Yeah, it's like a weird pig, I remember. Yeah, that's that has to be like an inside joke. I don't get it. The way strings are ordered is roughly alphabetic, but not really what you expect to see in a dictionary. Uppercase letters are always less than lowercase ones, so Z is lesser than A. Really? Because that's the exact opposite on how the alphabetized system works, alphabetical order works. And non-alphabetic characters, right, and so on, are also included in the ordering. Yeah, I knew that from playing Pokemon Go. You put special characters in front of your Pokemon, so it's easier to search. And all these weird symbols, they all have like their own priority. When comparing strings, JavaScript goes over the characters from left to right. Comparing the Unicodes one by one. Other similar operators are greater than or equal, lesser than or equal to, and not equal. Why would not equal be exclamation mark and equal sign? And isn't just an equal sign just equal to? Why does it need to be equal? All right. Itchy not equal to scratchy. Apple equal to orange. False. Okay. Is this what it returns, or is this what it returns once you apply this? Huh. There is only one value in JavaScript that is not equal to itself, and that is nan, not a number. Console. Okay, yeah, I remember nan. Nan is supposed to be the node itself with a nonsensical computation as such. It isn't equal to the result of any other nonsensical computations. So basically, nan is what should have happened in that Star Trek episode where they made the computer fry itself because it couldn't compute absurd behavior. So it should have just said nan, 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 nan. There are also some operators that can be applied to Boolean values themselves. JavaScript supports 3 logical operators, and, or, and not. These can be used to reason about Booleans. The and operator represents logical and it is binary operator. And its result is only true if both of the values are giving it to be true. true and false. False. True and true. Not sure how that's relevant, but okay. What is this? Sticks? How do you call this? The stick operator denotes logical OR. Produces true if either of the values give to it is true. False or true, true. False and false, false. So it defaults to true. Not is written as an exclamation mark. It is a unary operator that flips the value given to it. So exclamation true equals false, right? Yeah. Okay. When mixing these Boolean operators with arithmetic and other operators, and always obvious when parentheses are needed. In practice, you can usually get by knowing that of the operators we have seen so far has the lowest precedence that comes and n, then the comparison operators, and so on, and the rest. This order has been chosen such that, in typical expressions like the following one, as few parentheses as possible are necessary. Okay, 1 plus 1 equals 2. See, I don't understand why it can't just be 1 equal. 2 and 10 times 10 is greater than 50. Are these two separate problems? Okay. The last logical operator we'll discuss is not unitary, but binary. But, not binary, but ternary operator in 3 values. It is written with a question mark and a colon like this. False. Okay. No, I don't get it. Oh well. This one is called the conditional operator, or sometimes just the ternary operators. This is the only such operator in the language. The value on the left of the question mark picks the value on the left of the question mark. Okay. Picks which of the other 2 values will come out. When it is true, it chooses the middle value, which is the colon. And when it is false, it chooses the value on the right. Or the middle value would be, right, the 1, right? Oh, it's, okay. Comma is true, just one. Oh, okay. From the perspective of the colon. Left or right from the perspective of the colon. Okay. Empty values. There are 2 special values, written null and undefined, that are used to denote the absence of meaningful value. They are themselves values, but they carry no information. Many operators in the language that do not produce a meaningful value, you'll see some later, yield undefined simply because they have to yield some value. The difference in meaning between undefined and null is an accident of JavaScript's design. And it doesn't matter most of the time. In cases where you actually have to concern yourself with these values, I recommend treating them as mostly interchangeable. Automatic type conversion. In the introduction, I mentioned that JavaScript goes out of its way to accept almost any program you give it, even programs that do odd things. This is nicely demonstrated by the following expressions. Oh, okay. So no, it's not even supposed to be anything. And then how come, what, it ignores the parentheses? And this is adding the actual number 5 right next to the 1. I can kind of see why this happens. I can kind of see that. Yeah, because it doesn't know what this is. It doesn't know that that's actual 5. False equals 0. True. When an operator is applied to the wrong type of value, JavaScript will quietly convert that value to the type it needs using a set of rules that often aren't what you want or expect. This is called type coercion. The null in the first expression becomes 0 and the 5 in the second expression becomes 5 from string to number. Yet in the third expression, plus tries to try string concatenation before numeric addition, so the 1 is converted to 1 from number to string. When something that doesn't map to a number in an obvious way, such as 5 or undefined, is converted to a number, you get the value nan. Further, arithmetic operators on nan keep producing nan. So if you find yourself getting one of those in an unexpected place, look for accidental type conversions. When comparing values of the same type using equals equals, the outcome is easy to predict. You should get true when both values are the same, except in the case of nan. But when the types differ, JavaScript uses a complicated and confusing set of rules to determine what to do. In most cases, it just tries to convert one of the values to the other value's type. However, when null or undefined occurs on neither side of the operator, it produces true if both sides are of null or undefined. Right, because they're the same, right? I think they're the same. That behavior is often useful. When you want to test whenever a value has a real value instead of null or undefined, you can compare it to null with the equals equals or the not equal operator. All right. But what if you want to test whenever something refers to the precise value false? Expressions like 0, false, and double quotes equals false are also true because of an automatic type conversion. When you do not want any type conversions to happen, there are two additional operators, equal equals and exclamation double equals. The first tests whenever the value is precisely equal to the other, and the second tests whenever it is not precisely equal. But are these are for testing purposes? I recommend using the 3-character comparison operators defensively to prevent unexpected type conversions from tripping you up. But when you're certain the types on both sides will be the same, there is no problem using the shorter operators. Short-circuiting of logical operators. The logical operators and stick handle values in different types in a particular way. I think this is OR and this is logical AND, which I really don't know what logical AND means. They will convert the value on their left side to Boolean type in order to decide what to do. But depending on the operator and the result of that conversion, they will return either the original left-hand value or the right-hand value. The OR operator, for example, will return the value to its left when that can be converted to true, and it will return the value on its right otherwise. This has the expected effect when the values are Boolean and does something analogous for values or other types. Sure hope I can fucking memorize all this. This is like being a wizard. Gotta memorize all these little spells. We can use this functionality as a way to fall back on a default value. If you have a value that might be empty, you can put OR after it with a replacement value. If the initial value can be converted to false, you get the replacement instead. The rules for converting strings and numbers to Boolean values state that 0, nan, and the empty string count as false, while all other values count as true. So, 0 or -1 produces -1. And empty quotes or exclamation mark, question mark, yields, exclamation mark, question mark. The logical AND operator works similarly, but the other way around. When the value to its left is something that converts it to false, it returns that value, and otherwise it returns the value on its right. Another important property of these two operators is that the part to their right is evaluated only when necessary. In the case of true and x, no matter what x is, even if it's a piece of program that does something terrible, the result will be true and the x is never evaluated. The same goes for false, logical and x, which is false and will ignore x. This is called short circuit evaluation. The conditional operator works in a similar way. Of the second and third values, only one that is selected is evaluated. Summary. Jesus Christ. I don't know if I can memorize all this. Okay, this is like memorizing a bunch of like little cantrips, like tons of them. Memorizing a bunch of little cantrips. We looked at 4 types of JavaScript values in this chapter: numbers, strings, booleans, and undefined values. So those values are created by typing in their name, true, null, or value, 13 ABC. Right. You can combine and transform values with operators. We saw binary operators are for arithmetic, and string concatenation, comparisons, right, and logic, as well as several unitary operators. Minus to negate a number, exclamation mark to negate logically, and type of to find a value's type, and a ternary operator to pick one of the 2 values based on a third value. This gives you enough information to use JavaScript as a pocket calculator, but not much more. The next chapter will start trying these expressions together into basic programs. I finished chapter 1. I deserve a cookie. All right. Now I have to go to that webpage and read it. My brain's about to melt. So boring. A JavaScript Boolean represents one of 2 values, true or false. Boolean values. Very often in programming, you will need a data type that can only have one of 2 values, like yes, no, on, off, true, false. For this, JavaScript has Boolean data type. It can only take the values true or false. The Boolean function, parentheses, you can use the Boolean parentheses function to find if an expression or a variable is true. Boolean. It's 10 greater than 9, and it returns true. Try it yourself. For what? It's very simple. Display the value of Boolean. I didn't do anything. I didn't type anything. Okay. Or even easier. You mean I don't have to type Boolean? If I don't have to type Boolean, or even if I don't have to put parentheses, why would I? Comparisons and conditions. The chapter JS Comparisons gives a full overview of comparisons operators. The chapter JS Conditions gives a full overview of conditional statements. Here are some examples. Yeah, equal, greater than, lesser than. Got it. The Boolean value of an expression is the basis for all JavaScript comparisons and conditions. If age less than 18. Okay. Everything with a value is true. Examples, 10, blah, 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 blah. Any non-empty string is true. Okay, that's useful. Even the string false is true. Any expression except 0 is true. Okay. Everything without a value is false. Try it yourself. Okay, because the variable x equals 0, which means that there is no value. Doesn't have any value because it's 0. And 0 is the same as not having a value. Boolean value of -0 is false because it doesn't exist. Boolean value of empty string is false because the string is empty. Doesn't have a value. Boolean value of undefined is false, right, because it doesn't have the value. Boolean value of null is false. And I guess nan is false too. Boolean value of false is, you guessed it, false. Boolean value of nan is false. I guess that one. Booleans can be objects. Normally, JavaScript booleans are primitive values created from literals. Variable x equals false. But booleans can also be defined as objects with the keyword new. Var, which stands for variable, y equals new boolean, false. Alright, I just don't know how that's relevant. Never create booleans as objects. Ha! Booleans and objects cannot be safely compared. Boolean, object, okay? You can do it, but don't do it. You can do this, but don't do it. It's a bad idea. Do not create Boolean objects. It slows down execution speed. The new keyword complicates the code. This can produce some unexpected results. Then don't teach me it! When using the equal operator, equal booleans are equal. Variable x equals false, y equals new boolean, false. The result is x equals y. It's true because x and y have equal values. And if it has a value, it's true. When using the precisely equal operator, equal booleans are not equal because a precisely equal operator expects equality in both type and value, which is going to be false because it's not precisely equal. Or even worse, objects cannot be compared. New Boolean false, new Boolean false. False because objects cannot be compared. They're also false. And there's no value there. Note the difference between x equals y and x precisely equal y. Comparing two JavaScript objects will always return false. Complete Boolean reference. For a complete reference, go to our complete JavaScript Boolean reference. The reference contains descriptions and examples of all Boolean properties and methods. Do I have to? Alright, I just read that thing. I deserve a cookie. Cookie time. Oh. Mm. Mm. All right. Let's test my metal. Post your answers in Toshi Times. All right. Let's get out of here and get out of here. And open Toshi Times. Okay. I'm not gonna cheat, and I'm going to answer the best of my ability, even though I really wasn't paying attention when I was reading. Because I find it right now, my undisciplined mind finds it so boring. One second. Such is life. Anyway. Okay. Actually, I don't prefer to do it that way. I prefer to do it my way. Like this. With a 1, 2, 3. What are operators? They, come on. They are symbols that add or subtract values. But multiplication is not adding. Or is it a form of adding? Eh. No fucks given. What binary operators do you know? Okay. So plus, minus, forward slash, oh wait, binary operators. Well, yeah. Logical operators, do you know? Well, I know and. I know stick. And plus and minus can be logical. No, wait. No, they can't. And stick. Equals. And exclamation mark equals. Okay. Ha, I got that wrong. Boom, you got it wrong. Those are not binary. Binary is one thing or the other. How can that be? Okay, it's not comparing. This is a greater and lesser than or equals or not equal. Duh. Alright. What is the Boolean result of true, stick, false? So that is or. True or false will always be true. Yes, I got it. What is the Boolean result of true and logical false? True and logical false. That's the opposite, right? I'm gonna put false. Yes. What is the Boolean result of false or false? It's false. Boolean result of 5 greater than 4. True. What is the Boolean result of... Holy shit! Holy shit. Holy arcane magic. What is the Boolean result of... Okay, 4 times 2 equals 8. 8 is greater than 3. So it's 8 greater than 3. And 6 minus 3 is 3, which is greater than 20. Well, 3 is not greater than 20. So well, this is a true statement and this is a false statement. So it's going to be true. So I'm confused. Isn't this the same thing as putting true here and false here? Four out of 5. Not bad. I wasn't even supposed to be taking this course today. I plan on procrastinating. Oh, a video. Good. I passed the quiz. Get another cookie. Well, this time it's gonna be different. This is gonna be a cracker. Mm-mm. Mm-mm-mm-mm-mm. Alright. So to shut this down, I'm sure I'm gonna get a copyright strike for that bullshit. And, let's see. Well, I can't show you this, so... because my, Twitch is going to be banned before it even has a remote chance of growing. Turn that off, and what can I put instead of that? My friend code. If you play Pokemon Go, there's my friend code right there. Yeah, it's okay. You know what? I'm not playing Pokemon Go. I should just do due diligence. Okay. Alright, I'm just gonna leave it blank. Alright, play the video. Google Chrome and open up the console. Okay. You know what I could do? I could put it right here. Play it here. And then on this, I can open the console. All right. Developer tools. Actually, you know what? I'm gonna go here. It's blank. Okay. Excuse me. All right. So, open up the console and then what? Excuse me. Let's go on. Stop. I don't understand it. Okay. A and A is true. He creates a variable with var C equals true. Alright. And then he tries to C, and it returns as true. Oh, it's because A was true. He did the same thing with the A. So, because he did the same thing with the A and C, when you go A and C equals true. Got it. Right, because A and logical and B equals false, so it will be the same thing as going variable B equals false. It will be the same thing. It's the same thing. Right. And if one of them is true, then it's true. Stop, stop, stop. A or B, that one's true because one of them is true. Because it has or. C and K, C is true, K is false, but it has the logical and, which means that it's going to be false. And because you have one false, logical and is going to return false. I just don't know what good they are. What's the connection between Boolean expressions and like doing stuff? feel like I understand it, I'm not gonna play around with it because it's boring. Straight up. Okay? Straight up. Okay. Binding, functions, and control flow. Reading assignment. Okay, I can bring it back here now. Let's see. All right. Binding functions and control flow. Reading assignment. Welcome to this reading assignment on binding functions and control flow that will actually cover a lot. Great. Pick up our eloquent JavaScript book and read chapter 2 that starts with programming structure. Okay. Maybe I'll do that tomorrow. I think, I mean, what's bothering me so much is not programming. It's the school part, the studying and the reading, and I find it so tedious. You know, never did well at school, never wanted to do well at school, because the reading is so tedious. It's just filled with just filler text, and it doesn't get to the point. You know, and it just drives me crazy. You know, so anyway, all right, let's do one chapter a day. Okay, like one of these. About to jump out of my skin. All right. You need to love math. It's beautiful. That's funny. Well, maybe I'll see it as beautiful one day. You know. All right. So, I guess I'll see you guys tomorrow at 6. It's like 8:43 p.m. my time. So, yeah, right after work, I'll do another chapter. So, I think I don't know. I might return to work on my game. Something that excites me a little bit more. So, but we'll see. We'll see. Till tomorrow.